Okay, good morning everyone. Welcome for today's tutorial. Today we are going to dive into another branch of integration called integration by part. And I want you to pay attention to this because this is a very important topic under integration. Now let's look at integration by part. We apply the method of integration by part when a function is being multiplied, when two functions is multiplied, we use the integration by part formula. And the formula is given as you have the integral of u dv equals to uv minus the integral of what? V du. This is the formula of integration by part. And we apply this formula when we are about to integrate a function, a two function that is being multiplied together in form of product. That's when we use the method of integration by part. And this u is the function that we are going to differentiate. Is the function that we are differentiating. Our dv, this one, is the function that we are going to integrate. So the method of integration by part is applied when two functions being multiplied together, and we choose our u as a function that we are going to differentiate, whereby our v as a function that we are going to integrate to get v. So now let's look at how to solve example 1. We say we should evaluate the integral of x exponential x dx. Now if you look at the question that they gave us here, see that this question is in form of what? Product. We have two functions here. X is a function, whereby exponential x is also a function. So since we have two functions being multiplied, we use the method of integration by part. So let's look at how to evaluate this guy. Solution. We have what? Given integral of what? X of what? Exponential x dx. Now for us to integrate this guy, by the method of integration by part, the formula is given as integral of what? U dv, right? Equals to what? uv minus integral of what? V du. Now our u is the function that is easy to be what? Integrated, differentiated. Know that x can be differentiated, right? So let's say let our u be what? X, because we can differentiate x easily. Then our dv will be the function that we are going to integrate. So we say our v and our v be what? Exponential x. Exponential what? X. Now, for us to get our du, we must do what? Differentiate our u. So let's continue. From this guy, from u equals to what? X, right? Now for us to get our du, we say that our du over the x, right? When we are differentiating this function of u with respect to x, that is what du over the x means. Differentiating the function of what? U with respect to x. Because x is the parameter in this function. Now, equals to what? If you differentiate this guy by power rule, you know that this x is raised to a divisible power of 1. So when you bring out this one to multiply the function, you subtract 1 from the power by the method of differentiation. So we are going to have what? 1. Now, for us to get our dx, now this implies that we cross multiply our du equals to what? When this guy go here, become what? Dx. Now we are getting this guy. Now let's try to find the value of our v. From this function, you know that from here we have our v equals to our dv rather, sorry. Our dv equals to what? Our dv is equals to what? Exponential x. Exponential x. Now for us to get v, we are going to integrate the v. Now, for us to get b, if you integrate exponential x, it's the same thing as what? Exponential what? X. Now we are cutting all our parameters. We are cutting what? Our u is what? This implies that we are cutting all our parameters because our u, you know that our u is what? X. Our dv is what? Our dv is what? Our u is what? X. Our dv is what? Exponential x. dv is what? Exponential what? X. Now our u, we know that our u is already x, right? Our b is what? Our b is what? The same thing as exponential x. Our b is what? Exponential what? X. Now our du is what? Our du is this guy. Our du is what? The x. Our du is equal to what? The x. Now since we are getting all the parameters, we are going to substitute them into the formula of what? Integration by parts. Now let's substitute them into the formula. Okay, now let's substitute all these parameters into the formula of what? Integration by parts. You know that our integral, our u is what? We say that our u is what? X, right? We put our x here. Our dv is what? Our dv is what? Exponential x. We put our exponential x here. Equals to, this equals to, then our u is what? You know that our u is what? Already. We have x here, right? Our b is what? Our b is exponential x. So we put what? Multiply by what? Exponential what? X. We are done with this side. Minus, put our minus here. Integral. Our b is what? The same thing as what? Exponential x. We put it here. Exponential what? X. Our du is what? Our du is the x, right? We put our the x. Now, this is going to become what? Equals to exponential what? X, right? Minus. Now, if we integrate exponential x, we are still going to have what? Exponential of what? X. Because we integrate this guy with respect to what? X. So we are still having what? Exponential x. Since we are integrating, we introduce our constant of what? Integration, which is for c. Now, if you look at this guy, exponential x and exponential x is constant in this both sides. So we factor out exponential x. So this implies that the integral of what? X, exponential x, the x is equal to what? Now if you factor out this exponential x, since they are common, we will have exponential x as bracket. This x is here already. Then minus. You know that if you look at this exponential x, it will be 1, right? Plus what? 2. Because exponential x times s is going to give us s exponential x. Exponential s times 1 is equal to give us exponential s, and this is the final answer on how to integrate this s exponential s. Thank you very much. If you have any question, you can also drop it on the comment section. Let's move on to the second example on how to integrate using integration by part. Okay, example 2. This is to evaluate integral of x sin x dx. This is to evaluate integral of x sin x dx. You know that we cannot just integrate this guy directly using direct method or substitution method. Why? Because this is a function that is being multiplied. In that two functions they are being multiplied themselves. So in this form of a product. Since they are in the form of product, we apply the method of integration by part. Now look at how to evaluate this guy. Solution. Integral of sin s sin x, right? Now by the method of integration by part, the formula is given as integral of what? U dv equals to what? ub minus integral of what? V du. Now, from this point, you know that our u is the function that we are differentiating, while our dv is the function that we are what? Integrating. Don't forget that. So if you look at from this question, look at the function that is easily to be what? Differentiated. We call that function as what? U. Then the function that is hard to differentiate, we use it as what? Our integral, which implies that x and our u become what? Our u is what? X, because x is easy to be what? Differentiated. Then our dv, which is the function we are going to integrate, is our what? Sine x. Sine x. Now let's look at how to find other parameters. Now if you look at that, our u and our dv, right? Remember, what we're going to find now is our v and our du. So for us to find our v and our du, for this given expression, then look at from u equals to x, we are going to get our du. So from u equals to what? X. If you differentiate this function, du over what? The x is equal to what? If you differentiate x, it's going to equal to what? 1, right? Now for us to find du, we are going to make du the subject of the formula. This implies that our du equals to what? The x. Because when this x goes to the other side, we become what? Du equals to what? X. Now we are already gotten our du. Remain to get our what? V. And for us to get our v, we are going to integrate our what? Dv. So we say that from our dv, right? You know that our dv equals to what? Sine x, right? Sine x. For us to get our v, we are going to integrate our dv. Integrate what? Dv. And for us to integrate dv, you know that the integral sign cancel this there. So we are going to write with what? V. Now, when you integrate sine x, if you integrate sine x, we are going to have what? Minus what? Cos what? X. Now we are getting all the parameters. We are getting what? Our u as what? Our u as what? X, right? And we are getting our dv as what? Our dv as sine x, right? And we are getting our what? We are getting our v as what? Our v as what? Minus cos what? X. Now, we are getting all the parameters, right? We are getting u, getting dv, and getting what? Du. Now look at, now substitute. We substitute them into the function, the formula, substituting. Now we substitute into the formula, and the formula is what is given as what? Integral of what? U dv, right? Equals to what? uv minus integral of what? V du. Now we know that our u is what? Our u is x, right? So we have integral of what? X. Our dv is what? Sine x, right? Sine x. Then equals to, you know that our u is already what? X, right? This is this guy. Our u is x. Our v is what? Our v is minus cos x. This becomes minus what? Cos x, right? Then there is minus here. Minus the integral sign, right? This guy. Bracket. Our v is what? Minus what? Cos what? X, right? Our du is what? Our du. Know that our du is what? The x. Our du is what? The x, right? Our du is the x. So we put the x in place of the u. Now, this implies that x times minus cos x, we are going to have what? Minus x cos x, right? We are done with this guy. Minus. Now, minus times minus, there is minus here. Times this minus, you bring out this minus here, you going to become what? Plus, right? Now, the integral of what? Cos what? X dx. Now, this implies that we have minus x cos x. Now, plus, if you integrate cos x, you are going to have what? Sin x, sin what? X plus what? C, which is the constant of what? Integration. And this is our final answer. So this implies that the integral of x sin x dx is equal to what? Minus x cos x plus sin x final answer. This is how to evaluate this kind of what function in form of what product using integration by part. Now let's move on to the third example that we have on integration by part. Let's look at example 3. Example 3 says to evaluate the integral of s cos x dx. Now, for us to be able to evaluate this integral, you know that this integral is already in form of what product. We have two functions being multiplied themselves, right? So since we have two functions being multiplied themselves, we use the method of integration by part. So let's look at how to evaluate this function. Solution. They gave us an exponential integral of s cos x, right? Cos x dx. Now the secret is like, look at for the formula, we know that the integral of u dv equals to what? U v minus the integral of what? V du. Now, the major thing is for you to identify key parts in this formula. The key part is like our u is the function that we are going to differentiate. The function is very easy for us to differentiate. While our dv is the function that we are going to integrate to get v. So if you look at on this question, you know that s is easily to be what? Differentiated. So we say let u be what? Equals to x. Now our cos x, our cos x becomes what? Our dv, the function that is going to what? Integrated, which is cos x. From this part now, we are going to find the other parameters that is not in the question, which is we are going to find our v and our dv. Because our v, we have not gotten our v, and our dv, we have not gotten it. We can only have those functions or those parameters through by differentiating u to get what? Our du, and through by integrating v to get our what? V. So let's how to do it. Now from, you know that our u equals to what? X. Now for us to get our du, we are going to differentiate this function. So we differentiate u with respect to x, because x is the parameter in the function of u. So for us to differentiate x, we are going to have 1, right? And for us to find the u to be the subject of the formula, we are going to make the u the subject. And for us to make the u the subject, we cross multiply. This implies that our du becomes what? The x. We are already gotten our du now as the x. Now what we are going to find next is our v. And for us to get our v, you know that on this space, from the v equals to what? Cos what? X. Now for us to find our v, we are going to integrate this dv to get what? Our v. So this becomes the integral of what? Dv. Now look at this guy. The integral of dv equals to what? Equals to what? If we integrate cos, we're going to have what? Sin what? X. But look at this guy. You know that this integral sign cancel out this there. And this will be left by what? V. So our v becomes what? Sin what? X. Now we are got all the parameters. So this implies that you know that our u is already what? Our u is what? X, right? Then our dv is what? Our dv is what? Cos x. Now you know that our u is already x. Our v is what? Our v is what? Our v is sin what? X. Our du is what? Our du is the x. Our dv is what? The x. Now since we are getting all the parameters of this integration by part, we substitute them into the what? The formula. So by substituting, we have from the formula of integration by part, integral of what? U dv, right, equals to what? uv, right, minus integral of what? V du. Now, we know that our u is what? Our u is what? X, right? We put our x here. Our dv is x, right? Cos x, that's nice. Equals to, our u is what? You know our u is what? X, right? Put our x here. Our b is what? Our b is what? Sine x. Yeah, what? Sine x. There is minus here, right? You put your minus sign. Then the integral sign, you put it here also. Our b is what? Our b is sine x, right? You put your sine x here also. Our du is what? Our du is what? The x, right? You put your dx here. Put your dx here. So this implies that we're having s sine x, right? Minus. There is minus here, right? This minus. If you integrate sine x, you are going to have what? Minus cos x, right? Plus the constant of integration, which is c. So this becomes x sine x minus times minus is going to give us plus, right? That's nice. Cos x plus what? C. And therefore, the integral of what? X cos x dx is equal to what? X sine x plus what? Cos x plus what? C. This has to evaluate this kind of what? Function. X integral of x cos x using the method of what? Integration by part. If you have any question, you can also drop it on the comment section. Thank you very much. Let's look at another example on integration by part. Example 4, right? Example 4. They say you should evaluate the integral of what? S squared times exponential of x dx. Please, at this point, you need to pay attention because this guy we are going to solve now is somehow different from the one that we are solving. The other one we are solving, you know that our s was in power what? 1. But this one, our s is what? In power 2. So the secret of how to integrate this kind of function, check their power. If their power is what? If the power of what you are differentiating is power 1, you are going to do what? Just integrate by part by 1 time. But if the power is twice, do integration by part 2 times. If the power is of power 3, you do integration by part 3 times. That is the secret of how to evaluate a function using integration by what? Part. Now look at how to solve this guy. Now solution. We have the integral of x squared, right? Exponential x dx. Now, by the formula of integration by part, the formula is given as the integral of what? U dv, right? Equals to what? U v minus integral of what? V du. And I told us recently that this formula is letting us know that our u is the function that we are going to differentiate to get our du, whereby our dv is the function that we are going to integrate to get our what? V. So from the given function, what you are going to do first is to look at the function that is very what? Easy to do what? Differentiate. The function that is easy to differentiate, we call it what? U. The function that is not easy to differentiate, we call it what? dv. So look at this function. You have integral of x squared plus exponential s, right? The s, right? Know that s is power of 2 is easy to what? Differentiated, right? So you say let u equals to what? S raised to the power of what? 2, right? Now, our dv now become what? Our dv will be what? This one that is not easy to what? Differentiate. Call it what? Exponential what? X. Now we are getting u and dv. Next thing we are going to find our v and find our what? Du. So they can substitute them into this formula of integration by part. Because now we have not known the value of what? Our v. And we have not known the value of what? Our du. But we can get those values by differentiating this guy, we get our du, and integrating this guy, we get our what? V. So let's look at how to do it. From here, let's say u equals to what? X to the power of 2, right? First to get our du, we differentiate this function of u with respect to what? X. Why do we made the u the subject, so our du become what? This is x plus multiplied over here, we have 2x the x, right? This is our du. Now let's find our what? V. For us to get our v from this line, we have to get v from, you know, we have dv equals to what? Exponential x, right? Exponential x. For us to get our v, integrate dv. So integral of what? dv equals to what? If you integrate this exponential x, you're still going to have what? Exponential x. And you know that this integral sign cancels this there. So we're going to left with what? V. Our v becomes what? Exponential what? X. Now we are gotten all the parameters. We are gotten what? All the parameters. This implies that we know that our u is what? Our u is what? S square, right? Our dv is what? From this formula, our dv is what? Our dv is equal to what? Exponential what? X. Now, you know our u already as what? S square. Our v is what? Our v is what? Our v is equal to what? Exponential x, right? Exponential x. Then our du is what? Our du is 2. Our du is equal to what? 2x dx. 2x dx. Since we have gotten all the parameters, our first integration now will substitute those parameters into what? The formula. So this implies that for the formula we have integral of what? U dv equals to what? U v minus integral of what? V du. You know that our u is what? Our u is what? S square, right? Our dv is what? Our dv is what? Exponential x equals to, our u is what? S square. We put S square here. Our v is what? Our v is what? Exponential x. Exponential x, right? Then there's minus here, you put your minus. You put your integral sign here. Our v is what? Our v is exponential x, right? You put your exponential x. Our du is what? Our du is what? 2x dx. 2x what? dx. Now this implies that we are going to have s square exponential x, right? Bring out this constant out because of this integral sign. We bring out the constant of what? This constant 2 out. So we still have our minus here. If we bring out this 2 out so we can integrate here, we are going to have what? 2 here. The integral of what? Exponential what? X times x the x. Now if you look at this is our first integral, right? It's our first what? Integral by part. But this guy still have a product here. Because this is respect to x and this is x. There is still a product function here. So we are still going to integrate again the second time so we can eliminate this x. That is the purpose of using integration by part. So now our main focus now is to integrate this guy. So from this side, let's integrate this guy. Exponential what? S dx. Now for us to integrate this guy, we are still going to use integration by part. Because this is a product of two functions being multiplied. So we are still going to apply the method of integration by part. So we say for this guy, say let our u be what? The one that can be easily differentiated, which is what? X. Our v be what? Our dv be what? Equals to exponential what? X, right? Now at this point, from this guy, it differentiates u with respect to what? X. We are going to have what? 1. This implies that our du is equal to what? The x, right? From this guy. Now from this place, from dv equals to what? Exponential x. For us to get our b, we integrate what? dv, right? And if we integrate dv, exponential x is equal to what? Exponential x, right? I know that the integral sign here cancel this day, right? So our b become what? Equals to exponential what? X. Now at this point in time, we are going to substitute them into the formula of what? Integration by part. So let's look at how to do it. Integral of what? U dv, right? Equals to what? UV minus integral of what? V du. Now this implies that our U is what? You know that our U for this guy is what? Our U is what? X, right? Our U is X. Our dv is what? Our dv is exponential x. So you put your exponential x here. Then equals to our U is what? You know that our U is what? X, right? You put your x here. Our b is what? Our b is exponential x. You put your exponential x here in place of this b minus the integral sign. Our b is what? Exponential x. You put your exponential x here. Our du is what? Our du is the x. So you put your x here. Now this becomes what? Exponential x times exponential x minus, if you integrate exponential x, then we will have what? Exponential x, right? Now we are getting this guy. Integral of what? X exponential x at this guy. So we come back from this guy. The first integration we make here, the first integration by part we make here, which is x squared exponential x minus 2 exponential x dx. Now you know that you integrate this guy again, right? And all the value of this guy is being given here as x exponential x minus exponential x, right? So we are going to substitute back into this main first integration by part that we make here. So this implies that from our first integration by part, which was integration of x squared, right? X dx, right? Was given as what? You know that here we have what? We have x squared, right? Exponential what? X minus 2 integral of what? Exponential x times x dx, which is the same thing as, you know that this was exponential x, right? The x at b. On this place here, on this guy here. Our next step was that we are trying to integrate this guy again because they are product. They are trying to integrate them again. As we integrate them, this is what we have, which is this guy. So we are going to substitute them back into this guy. This exponential x times x is the same thing as x exponential x. Because multiplication is commutative, the application does not matter. This can start with exponential x times x, or it can start with x exponential x. They are the same thing because it's commutative function. Now you can have to continue it. This becomes what? You are going to substitute this value here that you integrate for this guy into this place. So this becomes what? Equals to, where I'm going to use this on the right hand side, equals to what? X squared that you have here times exponential what? X, right? Minus 2 integral of what? When we integrate this guy, what do you have? So when we integrate this guy, what do you have? We have this guy, which is what? X exponential x minus exponential what? X plus what? Integral of what? C. Integration by constant of what? C. But this is constant of integration, which is plus C. So our final answer becomes what? Our final answer becomes what? We have, if you look at this guy, we have something in common, right? Exponential x is common. Exponential x is common. Exponential x is common. So you see how exponential x squared, right? Exponential x. If you multiply this with everything in bracket, you will have minus what? 2x, 2 times minus 2 times this can equal minus x exponential x. Minus 2 times this can equal to plus 2 exponential x plus c, right? Now, since exponential x, they are common in both of this expression, we factor out exponential x. So this becomes what? This implies that we are going to have what? Exponential x outside bracket. We like it like what? X squared, right? Minus 2x plus what? 2 plus our constant of integration. So therefore, our integral of x squared exponential what? X, the x equals to what? Is equals to what? Exponential x bracket x square minus 2x plus what? Plus 2. Plus 2, this is 2. Plus 2 plus our constant what? Of integration. And this is the final answer. Thank you very much for being part of us today in this tutorial. If you have any question, you can drop it on the comment section. And if you are not subscribed to this channel, I will also appeal that you should subscribe to this channel. Share it with your colleagues, your classmates, or any student that you know that is in need of this video. Thank you very much. This is Simplify Us STEM tutorial with Balaga and Balagun Maths Academy. God bless you all. I'm very happy and grateful that you are here. Please subscribe to this channel, like the video, and share it. Thank you very much. See you next in our next tutorial. God bless you.